All right, here we are on our quadratic functions unit talking about falling objects. Okay, so we actually have to kind of think about quadratic functions, where quadratic functions, it is ax squared plus bx plus c. And we're going to kind of start making a connection with graphing. So this equation is going to be equal to y. And when I would graph this function, the graph is a parabola. Okay, and so these are two examples of parabolas. And so with our focus on falling objects, most of our falling objects are going to start either on the ground, go up, and then come back down, kind of like a football. Like if you kick a football, it always goes up and then comes back down. Sometimes we are at a specific height where we are starting. So on this one, you know, let's say you're at the top of your school building and you're throwing your math notebook over the side of it since it's the end of the school year, and it's like, hurrah! So again, it starts at some height, goes over, and hits the ground. So what I have here is the vertex of a parabola is the point where the parabola crosses the axis of symmetry. So real quick, another review with our graphs. The vertex is the lowest and highest points. Okay, we talked about this as like when we talked about increasing, decreasing, and the turnaround points. So it is the vertex. The axis of symmetry goes right through the vertex. Again, the axis of symmetry, this is the point where the graph reflects itself. So where you would create that mirror image. Okay, so that's the axis of symmetry. But the key thing is when we are talking about the graphs of quadratic functions, the graph is a parabola, and these are what the parabolas look like. Okay, so let's go ahead and get started with our first one. We have some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation for this object's height is h at time t seconds after launch. So h equals negative 16t squared plus 80t. How long will it take the fireworks to reach the ground? So just to kind of reread this real quick. So their fireworks are going vertically into the air from the ground. So we know the starting height. The starting height is at the ground. Gives us our speed, 80 feet per second. If the connection to science, this is your velocity. They give us the equation, h is our height, time, t is our time, sorry, and it's in seconds. And then we have our equation. The question is how long? So when we are wondering how long, that means that we are solving for time. Okay, so how long represents time. So if I look at this equation, I'm solving for t. Okay, so if we make the connection back here to our function, we're solving for x. So we are solving for the solutions. The very first thing that we are going to do is label h first, our height. So it says how long will the fireworks, how long will it take to reach the ground? So since we're starting at the ground, we want it to end at the ground, we're going to identify that h equals 0. Okay, so that is our ending point. So we'll go ahead and create our equation. 0 equals, we're going to use the equation negative 16t squared plus 80t. Okay, and then we're going to solve how we have so far this school year. So our first step is we're going to see if we can factor to solve. So let's see if there's a GCF. There is. Our GCF is 16t. If I factor out a 16t, I'm going to actually factor out a negative 16t. I'm making it negative because you don't have to, but I think it'll be easier in the long run, because when I take negative 16t squared divided by negative 16t, I'm left with a positive t. 80t divided by a negative 16t is a negative 5. Okay, and so this binomial, by factoring out that negative, it does look like what we're used to factoring with. So our next step here is we're going to take each of these two factors and set it equal to 0. So it'll be negative 16t equal to 0, t minus 5 equal to 0. And then we just solve for t. So we get t equals 0 and then t equals positive 5. Now remember, t is time, so we have 0 seconds and 5 seconds. And to draw this one, and I'm doing this just because it's notes, so I want you to do it for notes too. We're talking about fireworks. Now fireworks, they start at the ground, they go up, okay, they go off, but they do come back down, like the remnants of it, and they come back to the ground. So when it starts, our time is 0 seconds. Okay, so that's when you start with your launch. You launch it at 0 seconds. You have your maximum height, and then by the time it comes, all the remnants and everything comes back down, you have it at 5 seconds. So when it said, the question is, how long will it take the fireworks to reach the ground? So after it goes up and comes back down, it will take 5 seconds. So let's go ahead and write a sentence. So remember, when we are solving for t and we have t squared, we'll have at most 2 possible answers. You just have to think about which answer is going to make the most sense to answer the question. Okay, so let's go ahead and start number 2. So number 2, we have a penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by the equation h equals negative 16t squared plus 1,250, how long will it take the penny to strike a 6-foot tall person? So on this one, the penny is dropped off the Empire State Building. And it gives me the height. So this is my starting height, 1,250 feet. The penny's pathway, we have our equation. How long, so we're going to solve for time again, will it take the penny to reach a 6-foot tall person? So when I'm requiring you to label h first. We're going to go ahead and label h as 6. Okay, so we aren't going to go to the ground like we did on problem number 1. We're going to go to 6. We're 6 feet at the top of that 6-foot tall person. So I'm going to set up my equation, this time with h equaling 6, and not 0. It's going to be 6 equals and then negative 16t squared plus 1,250. Okay, we're going to set it equal to 0 though, because that is how we factor to solve. So I'm going to subtract 6 from both sides. I have the 0 equals negative 16t squared plus 1,244. Okay, now for this problem, I could factor to solve, and let's go ahead and see the GCF that goes into 1,244. I actually don't have this in my answer key, so we'll go ahead and do this real quick. 16 does not go into it evenly, so let's go ahead and try 8. 8 doesn't go into it evenly. Let's try 4. 4 does. And then real quick, we'll try 6. But it was 4 was my GCF that went into it evenly. So what I'm going to do is I'm going to factor out that negative 4. And then I'm left with 4t squared minus, and so I like having that minus right here and my first term being positive, and 311. Now, when I take a look at this, if I would keep factoring, I would do difference of squares. Well, I can't. 311, I know, is not a perfect square. I can show you right here real quick. Oops. It's not a perfect square. So when it's not a perfect square, we're going to use quadratic formula. Okay? So at this step, I'm going to go ahead and erase. And we're going to go ahead and use quadratic formula to solve this. I'm going to go ahead and start by labeling A is negative 16, B is 0, and C is 1,244. Okay? And so I'm going to create my equation here at the top. So it's not x equals, this time it's t equals, since I'm solving for time, negative b, which in this case is 0, plus or minus, the square root of 0 squared minus 4 times a times c. Okay, all divided by 2 times a, in this case is negative 16. And then my next step, I start simplifying. Okay, negative 0, I don't need to rewrite that. I'm just going to drop down my plus or minus. 0 squared, I don't need to write that, but I know negative times a negative is a positive. I'm going to go ahead and multiply these three numbers together, and I get a big number. I get 79,616 divided by negative 32. Okay, from here I'm going to go ahead and substitute this into my calculator and come up with my two answers. So the first answer is going to be the square root of 616. Make sure you close those parentheses, divided by negative 32, and I get a negative value. And then I'm going to try this over again, but this time I'm going to do it with my minus. So I'm going to insert that negative, and I get a positive value, rounding to the hundredths. Now, oops, it's a positive value. My negative value, we can't have a negative time, so I know my time is 8 82 hundredths seconds. Okay? Write that in there. So, the two examples that I have, sometimes we can factor, sometimes we can't, so we're going to rely on the quadratic formula. Okay? We'll go ahead and finish this up next time I see you in class.